In this video, we will see what is stoichiometry and how can we interpret a balanced chemical equation in different ways. So, we already learned how to balance a chemical equation and what is a balanced chemical equation indicates, right? Although the coefficients in the balanced chemical equation tells us how many atoms will react to form a specific product and how many atoms of products will be formed. But it will not tell us actual masses of reactant that reacted and actual masses of product that is formed, correct? So for doing that calculation, we need to relate the mole ratio of the reactants and products, and we can do that one using stoichiometry. So what is stoichiometry? We just learned that it is all about the ratios, correct? But by definition, we can say that it is a quantitative study of reactants and products in a chemical reaction. So these type of calculations are very important for a chemist. For instance, give you some examples for production of rocket fuel and also for the production of specific dose of medicine and even in food industry. Some examples, okay? So now, how are we going to use a chemical equation in different ways? How are we going to interpret for the stoichiometric calculations? So let us take an example of the production of ammonia from nitrogen and hydrogen. So we know this equation is balanced because we have 2 atoms of nitrogen and 6 atoms of hydrogen on the left side, and on the right side also we have 2 atoms of nitrogen and 6 atoms of hydrogen. We can also say that there is 1 mole of nitrogen on the left side and 3 molecules of hydrogen and 2 molecules of ammonia on the right side, correct? And how can we say in terms of moles? We can say that 1 mole of nitrogen on the left side, 3 moles of hydrogen on the left side, and 2 moles of ammonia on the right side. So whatever the coefficient is there, we can say that is the number of moles as well, correct? So from this we can take the ratio of moles to calculate how much product will be formed from a specific reactant, correct? And if you want to relate that in terms of particles, particles can be atoms, ions, molecules, anything like that, right? So here I'm going to show you in terms of molecules. So how many particles of nitrogen molecules are there? We know that in 1 mole we will have Avogadro number of particles, which is 6.02 times 10 to the power 23. So that is in 1 mole of nitrogen. So if we have 3 moles of hydrogen, 3 times of that, correct? That means 3 times 6.02 times 10 to the power 23 molecules of hydrogen. So how can we say for ammonia? That is 2 times, correct? Because the coefficient is 2. So 2 times 6.02 times 10 to the power 23 molecules of ammonia. So we can also relate in the same way in terms of mass. So what is the mass of nitrogen molecule? We can look in the periodic table and we can calculate the mass. When I round it, it will be 28 grams of nitrogen and 6 grams of hydrogen and 34 grams of ammonia. So we can take the ratio of mass if we want direct mass relationship. And what if we need in terms of volume? So we know 1 mole of any gas at STP will have a volume of 22.4 liters. That is constant, okay? So that is fixed volume. So if we have 1 mole of nitrogen at STP, we will have 22.4 liters. So in this specific equation, we have 3 moles of hydrogen. So we will have 3 times 22.4 liters of hydrogen. And we will have 2 times 22.4 liters of ammonia. So we can relate in terms of volume, we can relate in terms of mass, particles, moles, molecules, etc. Correct? So we can use this these ratios of the substances for the stoichiometric calculations.